In the project AI for real-time charging that was funded by the TrialsNet Horizon project, we developed the CNAP, Charging Network Analytics Platform. This analytics platform has been used in our trial that we did in an area of Athens that had to do with 5 charging stations of the EV loader network that's operated by Parity. This platform was able to run the use case that we have designed, and in this use case for 4 months we were monitoring the charging sessions of these 5 stations. This platform was interconnected with the CPMS, the production management platform for the charging stations of EV loader network, and was able to perform a load balancing. In the beginning of the charging, we started for 1 month, on January we started for 1 month doing just a reactive load balancing, and later on we activated AI forecasting. If we go and monitor the activity in one of these charging stations, which is the charging station complex of Four Seasons Hotel, we can see here on the top left the map that has to do with the charging stations. Currently we see the location of the charging station of Four Seasons. On the top right we see a diagram where we have the 4 plugs that the charging station has, and with the blue lines we see the charging sessions in all these months. The downgrade actions line indicates when we had to react and downgrade power because some breach was happening with the power limits. On the predicted periods is starting on February, when we activated AI forecasting, and then for some predicted periods the power was proactively downgraded because we anticipated peaks at that particular time. In some cases where these peaks were not anticipated, we see some red lines in the downgrade actions row, where we had to actually react to actual peaks that happened and were not predicted. On the bottom we can see also diagrams that have to do with the utilization and power usage. We can zoom in interactively and see the performance of this charging station. So for instance we can see a period where we had some predicted periods that we had downgraded proactively because we anticipated some concurrent charging, that the total power violated the limits that we had set. In this particular day, on 9th of February, there was an anomaly. We do not anticipate the peak, and this is that we had to do a reactive action at when we had, let's say, a fourth concurrent charging happening with a peak power. The reaction had to do with downgrading a particular charging session from 22 kilowatts to 11 kilowatts, and the new one started also with 11 kilowatts. Also we can zoom in and see utilization in the charging station within for every hour of the day, and also we can see the power usage. So the platform overall it performed pretty well. The AI forecasting reduced significantly the times where peak values were violated, but even in that case, 5G standalone connectivity enabled this platform to react fast and prevent problems on the electrical grid.